Okay, everybody, we're back here with the three-door problem, and hopefully in 5 minutes or less, I want to show you how we can create a little bit of code that's going to get us to solve this problem and run the simulation thousands of times and show us what the answer is, and enable us to do this when any number of doors are selected. So to do that, we're going to create a new, a short macro to get this done. So let's go into Visual Basic. I'll try and shrink this down to the level that we've got. And let's just do File, Insert Module. And let's start with a bit of coding. So first of all, let's call this something. So we'll call this sub procedure count switch wins. There you go. Eventually I got the syntax right. That's the trick with Excel VBA. It's very particular. So you got to get it exactly right. Right, let's ask for the number of doors. Dim number of doors. My space bar's not working properly. I don't know what's going on here. This must be the screen recording. Number of doors as integer. Integer is usually a whole number between 1 and 300,000, give or take, or 32,000 or something like that. Dim number, let's just dim number of simulations as long lets us get. And let's just, now we'll just start by number of doors equals 3, because that's the problem we were solving. Number of simulations equals 1,000. We'll just run it for 1,000. That shouldn't take any time at all. Okay, so now what we're going to do is we're going to loop through all of the simulations for sim count equals 1 to number simulations. And I'll just fix the missing spaces. And let's call simulations as long, sim count as long. It's a good practice to define your variables as you go. All right, so now we're going to loop, and then just to close that loop, we're going to say next sim count. Really got to work on this faulty space bar, huh? Okay, so everything within this segment is going to loop through 1,000 times. After that, we're going to display the result. So now let's start off with dim stick count as long. We're going to run this dim switch count. Let's call it switch win as long. All right, so this first thing is going to count the number of times sticking with your original choice wins. And the second one is going to count the number of times that switching wins. All right, so let's get into the probability of it. Let's first of all generate a random number. So let's call this my guess equals rand between, doesn't like that, but I do know there's a spreadsheet function. So we go application dot worksheet function dot rand between. Here we go. Dot rand between 1, comma, and now the number of doors. Number of doors. All right. What we're going to do is we are going to see if that works. Debug print the guess is ampersand my guess. Debug.print the guess is my guess. What that's going to do is show in this results window what the guess was. And what we want to see is a number between 1 and 3. We want to see evenly distributed. So let's just run that and see what happens. Expected end sub. All right, well, there you go. Thanks. Usually when you sub, it end subs. All right. Here you go. And then this gave me my results tab. It ran it 1,000 times, and you can see 1, 2, and 3 are distributed, probably evenly, but it is random. So, you know, the more simulations we get, the more it will be like a perfect, you know, distribution where each result arrives evenly. But if you did a random guess of only, let's say, 5 simulations, let's do it like that. Number of simulations equals 5. Let's just start there where that cursor is. There you go, 1, 3, 3, 3, 3. So here you see 3 is occurring more often than 1 or 2. And that's what's going to happen when you run a random simulator on only a small number of samples. So let's go back to 1,000. As we saw, that worked really quickly. All right, so you're guessing that. And let's go to say that the answer is exactly the same expression. Okay, so let's copy that, put that there. Okay, let's put that there. Then you say debug, print. My guess is this, ampersand. Oh, this space bar is killing me. And but the answer is there we go. All right. Oops. Let's run it again. My guess is 1, but the answer is 2. My guess is 1, but the answer is 1. Okay, so now this is working out very well. Now let's apply the logic test as to whether sticking or winning wins. So let's do this. If my guess equals, okay, normally the spacebar works right, but for some reason screen sharing doesn't. If my guess equals answer, then, just randomly frustrating me here, then stick win equals stick win plus 1. Else, now something important to remember here, so let's just set up these variables. Stick win 0, switch win equals 0. Let's set those variables to be the same. Else switch win equals switch win plus 1. End if. All right, so we're going to loop through all of those, and then we're going to display the result. For now, I'm just going to put it into a message box. A message box. Sticking. Ooh. 1. And then let's do, well, let's just do the simple stitch count. Stick, win, ampersand. It's really driving me crazy with sticking 1, stick win, and all right, and then let's pick the right message result that we want at the end of that, and let's just do the default button. Okay. Doesn't like that, so what doesn't it like about that? Sticking 1 and stick win, and switching 1 at switch win. Why doesn't it like that? Don't like it on its own. I'm going to have to edit this out. No, now it seems to like it. All right, that is going to come up with a prompt. It's going to tell you what the results were. Later on, we'll convert this into a, what do you call it? Into percentage terms. Okay, let's take a look at the code. So let's just go back and explain the theory. So in the way that that Monty Hall game problem showed, if you guess the right door, so let's go back to our spreadsheet. So you got 3 guesses, door 1, 2, and 3. You don't know what's behind each door. You make your initial guess. And Monty Hall will then, he knows where the real answer is, and he'll reveal another fake choice. Now, at this point, you don't know where the answers are. You could guess door number 1, and the answer could be door number 1. But to make this problem interesting for the audience, he's going to eliminate one of the bad choices and leave you with a choice. Now, obviously, if you were that contestant and you switched, but your original choice was correct, you would be very disappointed with that outcome. You'd be disappointed in yourself, like, how could I have switched and I lost? I was right all along. That's what makes it for good TV. But another option is, the right answer might be door number 2. You picked door number 1 as your first pick, and he shows you door number 3, and you think, am I going to stay with door number 1? Am I going to move to door number 2? He's revealed door number 3. In that case, you switch and you win. So the way that the problem always works is he's always eliminating all of the bad choices. So you can think of it like this too. So you pick door number 1, but the answer is door number 10. In a 10-door problem, he'll eliminate all of these doors, and you will simply think, well, I've got a 50-50 chance of getting it right, but actually that's not correct, because you've actually got a much higher percentage of getting it right, because when you picked door number 1, you knew you had a 10% chance of winning in a 10-door problem. Now he's eliminated all of the bad choices and simply leaves you with a choice of 2 doors. In the other side, this whole population had a 90% chance of winning. And so therefore, all of that 90% chance is now concentrated in a single door. That's why you're better off switching. And that's why the Monty Hall problem is easier to see with a large number of doors than it is with a small number of doors. Because here you think you're in a 50-50 shot. So let's go back to the code and let's see how this is running. So we're going to do 1,000 simulations. and it's going to display the result. So let's I'll just move it down here, and it's going to pop the result up on screen. So in 1,000 times, and using a random number generator, sticking 1 327 times, switching 1 673 times. All right, that is wonderful. Let's just put a little space in here. Right, so now we can change the number of doors to any number of doors that we want. So we had 3. Well, let's do this. Let's change it into percentage terms. So let's say let's figure that out in a moment. Let's first of all now do the 10 door problem. So I got 10 doors. We're going to run that problem to make our life a little easier. We'll create a little button here. There we go. Insert shape. Okay, and we're going to assign a macro to that. Right mouse click, lower down, it'll give you an option to assign a macro, and we'll do that. Okay, now we don't need to go into that code again. Run macro. So, if you did this 1,000 times, and there were 10 doors, you guess your first door, not surprisingly, you're going to win 1/10 of the time. So that should be close to 100. And the more simulations that we do, the closer it will get to, 10%. Switching 1 907 times. So switching always wins. Switching is, So now let's make this a little more fun. Let's take the code and ask for the number of doors. All right. So let's do this. So number of doors equals input box prompt, enter number of doors, comma. Well, that's it. And then it's going to run that number of doors. Here I've defined it just in case, but we don't need that. All right, now let's count the win percentage. All right, so let's just do dim win percent as percentage. I guess that's just long now. Dim switch. There we go. Right, we do all of our calculations. Now we say win percent equals, well, actually I should have called that stick win divided by the number of simulations. Win percent equals stick win, and then we've got stick percent, switch percent. I got to tell you, this keyboard is driving me crazy, and I think I know why. I think it's because I got too many Bluetooth devices running at the same time. Next time I do one of these videos, I'm just going to use a corded keyboard and eliminate that problem. All right, so we've got the percentages now. I'm going to call that, instead of win percentage, I'm going to call it stick. And I'm going to change this here to be stick also. All right, let's put it in percentage term. Sticking 1. Now, format, percent. I'm going to put that in there, stick. Number of digits, let's do 3 digits. Format percent, stick percent at 3, and switching 1, and we'll do this. So the format percent just gives you a nicely formatted answer, a nicely formatted percentage. Switch percent. All right, so we should be prompted for the number of doors that we want to run. We're still running 1,000 simulations. Let's go back and check the code. All right, here's my button. Enter number of doors. Let's go back to the 3-door problem. There you go. Ooh, got a glitch here. Sticking 1, 0%, switching 1. All right, well, this is real life macro solved macro coding. Stick percent equals stick win. You know what we're going to do? We'll put a little pause here. That's going to make, so let's have a look. I've got stick win divided by number of simulations. Number of simulations, it looks right. Switch percent. Maybe I got this thing wrong. Maybe I got my formula. Well, let's run it. What happens now when we run it, it's going to pause here and it's going to tell me what's in those variables. Number of doors, 3. All right. So it looks like it hasn't calculated a problem because the stick win is 364, the switch win is 654. Stick percent hasn't been calculated. Okay, that's easily done. All I've done is I put this in the wrong place. That has to be after all the loops have been completed. All right, well, let's test it out again. Still didn't work. Stick percent equals stick win 352 divided by number of simulations. Stick percent equals 0. All right. Stick percent as long. This doesn't make any sense. Oh. Here's the problem. Long just means long integer. Double means double decimal precision. All I had is I defined the variable wrong. Okay, so now we've got, well, we have a stick percentage of that, and we still have a switch percentage which didn't calculate. It hasn't recognized that, and that's because I foolishly didn't use an underscore. So let's just stop that one more time. Got answers for both. All right. There we go. All right, we are good on the code. Now, we're running it 1,000 times. There you go. So, any number of doors we want to put in. Obviously, I could do some error checking here to just eliminate bad choices, like what if somebody puts 1,000 doors, or what if somebody puts just 1 door? Well, Monty Hall game show is not going to work with just 1 door. So, but here you see that if there are 10 doors, and in fact we could probably, let's just put in here. So let's put in the code, give it a little more context, and just say with, and then we're going to say ampersand. I'm going to use number of doors, number of doors, number of doors. So now I'm going to say with 10, I'm going to say doors, comma, sticking 1, X%. All right, now we've got a bit more context. Run macro, number of doors, 3 doors. With 3 doors, sticking 1, 34%, switching 1, 65%. All right, and let's just tidy that up a little bit. Make it look a little more professional, put an extra space in there. All right, let's run it for 1,000,000 simulations. 1,000, 4, 5, 6. Okay, we're going to run this for 1,000,000 simulations, and let's test how quickly it is. All right, how many doors do you want? Pick a number, any number you want. Anyway, so let's just test it out. 3 doors. Ooh, it's thinking. It is thinking. Oh, there you go. With 3, it took probably about 5 seconds, yeah, maybe 3 seconds. With 3 doors, switching 1 33% of the time, sticking 1 66.679. As you can see, the more simulations, the more that ran between generates every response evenly. And so this is kind of predictable. We know that with 3 doors, our first guess is going to be right 1/3 of the time. So the more times you do it. Now, we'll do something a little more. We'll up the number of counts in a little while. Let's do it again. Okay, number of doors, 10 doors. If you ran the simulation 1,000,000 times, you've got 10 doors, your first choice is going to be right 1/10 of the time. Let's check it out. Okay, it's working on it, and it will come back. There we go. So that's probably about 3 seconds. With 10 doors, sticking 1 9% of the time, switching 1 90% of the time. So there you have it. And, you know, I guess the more, let's just make that, or if I make that 2,000,000, because I'll be conscious of the fact for this video it's going to take 6 seconds, but actually, you know what? So let's do 10 doors. All right, it's running away. So it's going to get closer and closer and closer to 10% when we're running 2,000,000 rows of data. So let's see what happens. There we go. With 10 doors, sticking 1 10.033%, switching 1 89.967%. All right, so I'll do one last go at the Monty Hall problem. You probably never ran it for 2,000,000 iterations, but if you did, then the result would be that switching will win the majority of the time. And here we go. It's 66.8681% with 3 doors, and that's over 2,000,000 simulations. So there you have it. The Marilyn Hall prediction was entirely correct. This is a nice little bit of VBA code for you. So if you would like to replicate this code in Excel, here it is. You can just copy and paste it or delete out some spaces. So you can simply screenshot it, point your phone at it. Your phone will recognize the text, and then you can have at it. Put it into Excel. You could put it into a different programming language. You could do Python. You know, the calculations are pretty straightforward. You basically, whatever the number of doors is, you've 10 doors, you've got a 1/10 chance of getting it right. Generate 2 random numbers. We don't need that anymore. Generate 2 random numbers and see if they're both the same. And that mirrors the probability that your guess was right at the first time. And obviously, if your guess was right, then sticking with that choice would have been the best choice. If your guess, then Monty Hall does his thing, close off your choices. If switching's right, then, you know, if those 2 numbers are different, then switching is the is the best choice. So there you go. Here's a nice bit of code. Cut it out, use it. If you actually want a copy of this spreadsheet, just drop me a link, and if there's enough interest, I'll put this out on my blog. So there you go. That was a fun little experiment. I started off the morning productively. I hope some combination of these cameras are recording everything, and have fun.